These experiments involve Newton's second law of motion. A truck with an acceleration will cause the elevator to move upward or downward through a pulley.
So let us first move to the pulleys. Pulleys are simple machines that use a groove wheel and a rope or cable to change the direction of an applied force. So they allow us to lift heavy objects with less effort by applying Newton's second law. So we will pull down rope that attached to a pulley. We will apply force. This force is transmitted to the object being lifted, which may have its own mass. So the system acceleration depends on the net force and the combined mass of the object and the rope. So furthermore, pulleys provide a mechanical advantage by spreading the force needed to lift an object over multiple ropes and pulleys. The more pulleys in a system, the greater the advantage, but the distance the rope must be pulled also increases. That is all for pulleys. So now let us move on to the lifts and elevators. Elevators in buildings operate based on the principle of Newton's second law. So the motor generates a force to lift or lower the elevator car and its occupants. The acceleration and speed are controlled to ensure a smooth ride. So in addition, many lifts and elevators use counterweights to balance the load. Counterweights are designed to offset the weight of the elevator car, which make it easier for the motor to lift up or lower it down. Therefore, understanding Newton's second law is crucial in elevator design and regulation.
Now, let's dive into the fascinating world of physics and discover how these principles govern our everyday experience. Newton's second law states that the acceleration of an object is directly proportional to the net force applied to it and inversely proportional to its mass. In mathematical terms, F equals to ma, where F represents force, m is mass, and a is acceleration. Friction is a force that opposes the relative motion or tendency of motion between two surfaces in contact. It's represented by the equation F equals micro times the normal force. Here, micro is the coefficient of friction, and n is the normal force exerted by the surface. There are two main types of friction, which is static and kinetic. Static friction prevents an object from moving when you apply a force. Kinetic friction opposes the motion of an object that are already in motion. Next, thrust is a force that propels an object forward. In the context of Newton's second law, in a car, the force produced by the engine making the car to move forward. It represented by the equation force equals to power divided by velocity. Besides, weight is the force with which gravity pulls an object towards the center of the earth. It calculated using the equation weight equals to mass times gravitational acceleration. Newton's second law is a fundamental principle that explains how forces like friction, thrust, and weight affect the motion of objects.
After a simple proof of Newton's first law, second law, and third law, let's move back to our experiment. These experiments involve Newton's second law of motion. A truck with an acceleration will cause the elevator to move upward or downward through a pulley. This experiment is meant to solve our problem. If a truck accelerates and moves forward or backward, how much forces are applied to the elevator in order to move upward or downward? In this experiment, we can find that there's a lot of forces acting on an object. For example, a truck moving on a rough surface, a frictional force will occur.
So, in this experiment, we had created some question that is very related to the experiment above. In order to find the mass of the object inside the lift, we first have to find the normal force which is acting on the truck, where we calculated 44,000 Newton. This is very important because it will determine the speed, the acceleration, and the deceleration of the lift. So, on the question, we have set the mass of the truck, which is 10,000 kg, where it is very much compared to the mass of the lift, so that it can move the lift easily without any other force acting on the truck. Next, we calculated the frictional force acting on the truck, so that we need to know how much thrust force applied to move the lift at a certain acceleration. After that, we can't ignore the tension of the string. We need the string to be strong enough that it won't be elastic or snatch while pulling the lift. Lastly, we calculated the object mass inside the lift, whether it will be heavier when the lift is accelerating and it will be lighter when the lift is decelerating. So in the calculation, we have proved that a 65 kg object will be heavier when accelerating and lighter when decelerating. Free fall is when the rope breaks, where the gravity is equal to acceleration. We have calculated both force on elevator and the object, but soon find out that the mass will not affect by the speed of free fall, since both acceleration are the same, which is 9.81.
That comes to the end of the video.
By doing this experiment, we get to know more about Newton's second law.
Thank you for watching our video. We hope to see you